will be solving question number 7 of GATE Chemical Engineering paper, and the subject is related to heat transfer. The question is, in a double pipe heat exchanger of 10-meter length, a hot fluid flows in the annulus and a cold fluid flows in the inner pipe. The temperature profiles of the hot TH and cold TC fluids along the length of the heat exchanger X such that X is greater than 0 are given by these two equations, where TH and TC are in degrees Celsius and X is in meter. The logarithmic mean temperature difference in degrees Celsius is, so we have an MCQ type of question and we have been asked to find the log mean temperature difference LMTD for this double pipe heat exchanger. Okay, so here we are having double pipe heat exchanger, so let's just make a schematic of that. And the hot fluid flows in the annulus and cold fluid flows in the inner pipe. Okay, so this is my TC, and let's just consider the hot fluid enters from this side. Okay, so this kind of flow is known as co-current. If it enters from the opposite direction, then it is known as counter current. Okay, and we have been given the temperature profile. So from the temperature profile for this hot fluid that flows in the annulus, we can see that the slope of that line is negative. That means if I keep on increasing X, then TH decreases. Okay, so if this is my X direction, okay, so if I am increasing X, then the temperature of hot fluid will decrease as per this equation. And so if we are considering the co-current flow, then that would satisfy. That is, as I move along the pipe, the temperature of the hot fluid will decrease. So that is why we are taking it as co-current. If we had taken it as counter current, then the slope should have been positive. Okay, so that is why we are taking a co-current flow. Okay, so if I had to draw temperature profile, I can draw it as, this is my X in this direction. So for the hot fluid, the temperature is decreasing, so this is my TH, and for the cold fluid, the temperature is increasing, so this will become TC. Okay, now we have this log mean temperature difference definition as delta T1 minus delta T2 upon ln of delta T1 upon ln of delta T1 upon delta T2, where delta T1 is my temperature difference. You can take it as at inlet, and delta 2 is temperature difference at the outlet. Okay, so let's just find in general delta T at any X. Okay, so that will be temperature of the hot fluid at X minus temperature of cold fluid at X. So it will become 80 minus 3x minus of 20 plus 2x. You can solve this and it will become 80 minus 20 is 60, minus 3x minus 2x is minus of 5x. Okay, so my delta T at any X is 60 minus 5x. Now for delta T1, x1 is x is equal to 0. So we will be getting delta T1 is equal to 60 minus 5 of 0. So we are considering right now this point, that is my x equal to 0. So it will become 60. Similarly for delta T2, we can take x equal to the L, and we have been given the length as 10 meter. Okay, so this is 10 meter. Similarly delta T2 will become 60 minus 5 into 10, it will become 60 minus 50 is 10. Okay, so we have delta T1 and delta T2. Based on that, we can calculate my log mean temperature difference. Okay, so delta TL is equal to delta T1 minus delta T2 upon ln of delta T1 on delta T2. So delta T1 was 60 and this is 10. Okay, so it will become 60 minus 10 upon ln of 60 upon 10. It is 50 upon ln of 6. So you can solve this using the calci and this value will come around 27.9. So our log mean temperature difference is 27.9 degrees Celsius. So from the given option, our B option is correct, 27.9 degrees Celsius.